So good morning dear cadets. So today I am going to teach you radioactivity. Just see, in the last video what I taught you? I taught you basically regarding the atoms, Dalton's theory. Then what about atomic theory of Dalton's, their drawbacks, everything we have discussed. Now in the row what I should teach? Models of atom. So the models of atom in 11th class you have studied. Radioactivity you have not studied. That is why it is better to teach this one. In models of atom, how many models are there? Thomson model is there, Bohr's model is there, Rutherford model is there. Then what is there? Some other aspects of atom is also there, like Planck's quantum theory is there, okay, de Broglie equation is there, Heisenberg uncertainty principle is there, different types of quantum number is there. So Above principle, Hund's rule, Pauli's exclusion principle, everything you have studied in detail in 11th class. So there is no need to teach same thing time and again. If you have got the book or notes, very easily you can revise that one, and definitely you will understand also. Just revision is required. There is no much what to say workforce is involved in those concepts, because in 11th class you have studied it properly. Okay. So now radioactivity. What do you mean by radioactivity? Radioactivity. Just see. This word is very, very familiar with each and everyone staying in this universe, very much aware. Just try to understand. Radioactivity is discovered accidentally by Henry Becquerel in year 1896. 1896. Actually, he was performing some other experiment. Unfortunately, his photoelectric plates got affected by one substance which was kept in drawer. Okay, so then he realized that substance, means the substance which was kept in the drawer, that has emitted some radiation. Because of that, photoelectric plates were disturbed or destroyed. So he found that some invisible rays are coming. So those invisible rays he told radioactive rays. So just see, of course radioactivity was discovered by Henry Becquerel, but this term was coined by the Madame Curie, and you know that Curie family is known as Nobel family, and they means her entire family directly or indirectly worked for the natural radioactivity or artificial radioactivity. And now there is no need to tell about the Madame Curie, but you just remember this one. This term was coined by the Madame Curie. Okay, and SI unit of radioactivity is Becquerel, in the honor of Henry Becquerel. This unit is known as Becquerel. 1 Becquerel equal to 1 disintegration per second, and 1 Curie equal to 3.7 into 10 raised to the power 10 disintegration per second. Okay, so this is all about the introduction of radioactivity. Actually, what is radioactivity? Radioactivity is nothing but a spontaneous emission of alpha, beta, gamma rays from the nucleus of an unstable atom. What is this one? Radioactivity? Spontaneous emission of alpha, beta and gamma rays from the nucleus of unstable atom. Okay, just try to understand spontaneous emission of alpha, beta and gamma rays. Okay, question arises here, what kind of atoms be considered unstable? What kind of atom be considered stable? So just see, actually radioactivity is a nuclear phenomena. Do you understand the meaning of nuclear phenomena? Means the reactions in which nucleus are involved, that is known as nuclear reactions. So radioactivity is an example of nuclear reaction. Reaction in which electrons are involved, they are known as chemical reaction. Okay, so generally what is there in our syllabus, all reactions are chemical reactions because electrons are taking part. but in radioactivity nucleus take part. That is why it is a nuclear reaction. So nuclear reactions are those reactions where nucleus is involved, and in the nucleus how many particles are there? 2 particles, proton and neutron. So roughly what we can say, in radioactivity proton and neutron is taking part. Okay, proton and neutron is taking part. Now let us come back to the basic question. What kind of nucleus or what kind of atoms we should consider stable? So just see, the stability of an atom is considered on the basis of N/P ratio. What is N/P ratio? Neutron proton ratio, N/P ratio. If N/P ratio is greater than 1.5, this is known as unstable atom or unstable nuclei. If N/P ratio is exactly 1, this is stable. What is this one? This is stable. Try to understand, there is one more criteria, mass defect. What is the meaning of mass defect? The difference in the mass of nucleus and its constituents. What are the constituents? Proton and neutron only. So if mass defect is more, then atom will be in the less energy state and it will be more stable. So what should be there? Substances or atoms which are of radioactive in nature, their mass defect is less. Means what is there? Their mass is more. That is why they are considered to be the unstable. Okay. So what should be there? N/P ratio should be greater than 1.5. Then they will be unstable and they only will emit the alpha, beta and gamma rays. Okay. So here what is there? One important thing is there. Will tell you when will teach you the properties of alpha, beta and gamma rays. So dear cadets, as you know, during the radioactive substance disintegration, there are 3 types of rays emitting, alpha, beta and gamma rays. So what are the properties of these rays? Just see. Alpha rays is represented by helium nucleus. Helium nucleus means what is there? Electron is not there in the helium. So if electron is not there in the helium, it can be represented by He2 positive. So what we can say? Alpha rays are nothing but a doubly positively charged helium nucleus. Doubly positively charged helium nucleus, that is known as alpha rays. What about beta rays? Beta rays are nothing but a electron, -1 E0, -1 E0, that is the representation. Gamma rays are nothing but a electromagnetic radiation of very high frequency, and they are represented by gamma sign only. Okay. Now here one question is there. What is that question? Just try to understand. What we can say, that it is a nuclear reaction. Radioactivity is nothing but related with the nucleus. So in the nucleus, what is there? 2 particles are there, proton and neutron. So where does this case arise? Beta rays. Beta rays are negatively charged particle. You just see, in the nucleus proton is there. Proton is a positively charged particle and neutron is a negative, means a neutral particle. So where negative charge has come in the nucleus? Try to understand. Means there is a big question mark, that how is beta rays emitted from the nucleus of radioactive substance? Very simple answer is there. Try to understand. In the nucleus, electron is not there, but alpha rays, they disintegrate into beta rays. Means helium, this helium nucleus, alpha rays disintegrated into electron, and those electrons which are present in the nucleus, now they combine together and form rays, that is known as beta rays. So result of emission of beta rays is because of the disintegration of helium nucleus disintegration. Remember this one. Because of the disintegration of helium only beta rays come out. Otherwise there is no chance of emission of beta rays, because beta rays are negatively charged rays, -1 E0. Okay. Some other quality is also there. Just see. Suppose from one unstable nucleus is there. From that unstable nucleus, one alpha ray is emitted. So once one alpha ray is emitted, so the resulting product or resulting element which is formed there, their atomic number will be decreased by 2 and mass number will be decreased by 4, means as compared to the original substance. Okay, suppose X is the original substance and it is emitting 1 alpha rays, and suppose Y is formed. So in Y what should be there? As compared to the atomic number of X, Y will have 2 atomic number less. As compared to X, Y will have 4 mass less. Okay, so these are the things. Now what are the other qualities of this one? Alpha rays means if you put electrodes or electric plate on their path, so alpha rays will be deflected toward the negatively charged plate. What does it indicate? It indicates that alpha rays are positively charged. Similarly, beta rays will be deflected toward the positively charged plate. It means beta rays carry the negative charge. What about gamma rays? Gamma rays remain unaffected from both types of plate. They will not be deflected either side. It means they are without charge. They are neutral, without charge. Now, if mixture of gas is there and you are supplying alpha rays, so alpha rays will produce the maximum ionization in the gas, maximum ionization, because their mass is very high. What about beta rays? Beta rays will produce the ionization, but as compared to alpha rays, less. And now what about this one? Gamma rays are electromagnetic radiation of very high frequencies. Then what would be there? They will produce the least ionization. What would be there? Least ionization. What about this one? What about this one? Alpha rays. Alpha rays penetration is minimum. Their penetration is minimum. Alpha rays penetration will be minimum. Penetration means ability to penetrate anything. So their mass is more, that is why their penetration power is less. Beta rays is better penetrating than alpha rays. The maximum penetration power gamma rays will be there, because their mass is least, very easily they can penetrate. Okay, so this is all about the properties of alpha, beta and gamma rays. So dear cadets, now disintegration theory. What do you mean by disintegration theory? Try to understand. If one radioactive substance starts disintegration, so it will keep on disintegrating until one stable non-reactive element is formed. Are you getting my point? What is the meaning of disintegration theory? Disintegration will keep on until one stable non-radioactive substance gets formed. That is the meaning of disintegration theory. Means until the formation of non-radioactive substance, now disintegration of radioactive substance will keep on. That is the meaning of disintegration theory. Now there is one more law, group displacement law. What do you mean by group displacement law? Very easy, just see. There are 3 types of decay: alpha decay, beta decay and gamma decay. If there is the emission of alpha rays from the nucleus of an atom, radioactive substance, then its atomic number, its group number, its atomic number will be decreased by 2 and mass number will be decreased by 4, and resulting atoms group will be displaced by left of the original substance. Just see here, radium is the member of second group, beryllium, magnesium, calcium, strontium, barium, radium, that is the member of group number 2. Now if one alpha rays is emitted, then what will be formed here? Radon, and radon is the member of group number 18. So just see, 2 group is left hand side. Okay, just see another one, lead. If beta rays are emitting, so the resulting element will have one group ahead than previous element. Just see, lead is the member of 14th group, carbon, silicon, germanium, tin, lead, 14th group member. Now one beta rays is emitting, so now what is formed here? Bismuth, 83. With the emission of beta rays, mass remain unchanged, but there is a increase in one atomic number. Just see, it was 82, now it is 83. What about alpha rays? There is a loss of 2 atomic number, 88, now here 86. So in case of emission of beta rays, there is a increase by 1 unit positive charge, means proton number, atomic number is increased by 1 and mass number remains constant. In case of emission of alpha rays, there is a decrease by 2 unit of atomic number and mass number by 4 unit. So what is there? Group displacement law means there will be change in their position in the periodic table. If alpha rays are emitting, then elements will have two place left hand side of the original substance, and in case of beta emission, one place right hand side of original substance. Lead to bismuth, lead is the member of 14th group, bismuth is the member of 15th group. This is known as group displacement law. In case of emission of gamma rays, there is no change in the position of resulting elements or resulting radioactive substance. There is no change because they are the electromagnetic radiations. In this way, group displacement law is also over. Another thing is nuclear fusion, nuclear fission, nuclear reactors. So dear cadets, just like a normal substance, here also for the radioactive substance a half-life period is there. That is represented by T half, and T half equal to 0.693 divided by lambda. Lambda here, what is there? What is the meaning of this one? What is the meaning of this one? This is the rate constant for the radioactive substance. For the usual substance, you put here K. For the radioactive substance, rate constant should be represented by lambda. This one. Average life equal to 1 by lambda equal to 1.44 into T half. What is the half-life period? Half-life period is the time at which the half of the concentration of the substance disintegrated. That is the half-life period. Half-life period of radioactive element is independent from its amount. Just see, Nt equal to N0 into half raised to the power n. Total time T equal to T half into n, where N0 equal to initial amount, Nt equal to concentration or amount after time T, and n equal to number of lives. Now the most important thing is nuclear fission, radioactive reactors, and application of radioactive substances. Just try to understand, in 9th class there was one substance, Geiger-Müller counter. So Geiger-Müller counter is the instrument by which we can measure or determine the activity of radioactive substances. Means we can count the emission of alpha, beta and gamma rays. So now nuclear fusion. first nuclear fission. Okay, fission means breaking. Nuclear fission, FISSION. Just see, this is the process in which bigger nuclei disintegrated into small nuclei with the introduction of neutron. Just see, this is uranium 92-235. If one neutron is introduced, what is introduced? One neutron. So this will be disintegrated into barium 56-141 plus krypton 36-93 with the emission of 3 neutron. So just try to understand. If you add this one, 235 plus 1, 236. Similarly, if you add this side, so this also be 236 only. Okay, so just see, 141, 93 and 3, 6, 7. Actually, this is 92. So here 92, just 3 to 5, 6, and this one 236. This side also 236, this side also. Why I wrote 3 here? Because 3 neutron, 1 neutron equal to 1. So 3 neutron equal to 3. Similarly, here what is there? 92. Now if you add 56 and 36, so this is equal to 92. So this reaction is known as nuclear fission. Just see, uranium was the big nuclei. This is disintegrating into barium 56, krypton 36 and 3 neutron. Just see, nuclear fission is 2 types: controlled nuclear fission and uncontrolled nuclear fission. If it is uncontrolled, just see, with the introduction of 1 neutron, 3 neutron is released. Means 1 neutron can disintegrate 1 uranium, and with the disintegration of 1 uranium, 3 neutron is released. So they can disintegrate 3 more uranium. Now remember, with 1 neutron, 3 neutron is released. Okay, so with 3, how many will be released? 3 plus 3 plus 9 will be released. Now 9 further, you can understand. So if just try to understand, controlled nuclear fission means when we can control the activity of this neutron. Okay, so now here huge amount of energy will be released, and this energy is the only matter. If this neutron activity is controlled, it means this is controlled nuclear fission reaction, and this reaction is only taking place in the nuclear reactor, which is used for the electricity generation. If this neutron reaction is not controlled, so this will be resulting into formation of atom bomb and devastation. You might have heard about Hiroshima and Nagasaki. So the atom bomb principle is nuclear fission only. Correct or not? Controlled nuclear fission reaction resulting into the formation of production of huge amount of electricity, which can be used for the betterment of mankind. But uncontrolled amount of energy which is released, which can be used for the destruction of human and human property. So this is the nuclear fission. What about nuclear fusion? In nuclear fusion, what is there? Nuclear fusion. In nuclear fusion, so many small nuclei get fused. Just see, 1H1 plus 1H1, that is equal to 2He2. Okay, now this 2He2 further react with another 2He2, and it will form, means you can write here 1H2. So it will form 2He3. Now this 2He3 2He3 will further react with 1H or you can say here write H1H1, 1H1. So this is 3He3. Now here what is there? 3He3, 1H1, that is equal to He4. Okay, 2He4. Please don't write here 1. Here also just write 2He3. 2He3 plus 1H1 equal to 2He4. Here H1 only, neutrino, yes, 1 only. So try to understand, nuclear fission means fusion of small nuclei, fusion of so many small nuclei. When so many small nuclei fuse, what is there? Here also amount of energy is released. What is there? Energy. In each step energy is released. What is released? Energy. Here also what is there? Energy is released, and this energy can also used for the production of hydrogen bomb. Since this reaction takes place at very high temperature, that is why it is known as thermonuclear reaction. Thermonuclear reaction. This thermonuclear reaction, just try to understand, used for the production of hydrogen bombs. Now try to understand, this energy is the only source of energy for the stars and sun. In the core of sun, this nuclear fusion is only taking place. Now what are the reactors? Nuclear reactor. Nuclear reactor is the device where nuclear fission reaction is taking place in controlled manner, controlled phase. In the nuclear reactor, what is there? Fuel rod will be there, that would be of the uranium only. Moderator would be there, moderator may be graphite rod, and heavy water, that is B2O. Some other moderator means which can control the speed of neutron, they are the moderators. Similarly, some other devices are also used which can absorb the extra neutron, because if neutron number is more, then problem would be there. These will be the boron and cadmium rod. They are the absorber of neutron. Okay, so in this way, if this can be done, means nuclear fission can be taken place in controlled way, then massive amount of energy can be generated. Energy can be generated, which can be used for the betterment of human being. Now what are the uses of radioactivity? Uses, just see. You might have heard about cobalt-60. This is radioactive isotopes of cobalt, which is used in the treatment of cancer. Okay, you might have heard about this one, iodine-131. This is the isotopes of iodine which is used for the treatment of goiter. And what is else now? There are so many. Sodium-24. This is used for knowing the obstruction in the blood flow in the arteries. Similarly, smooth blood flow. You might have heard about the blockage. To detect the blockage percentage in the arteries, this isotopes is used. Carbon-14. What is the use of carbon-14? Carbon-14 isotopes is used for the determination of path of photosynthesis. So in this way, dear cadets, your entire radioactivity is completed. There are various uses of radioactivity. We can't confine the uses of radioactivity up to 4 or 5 uses. There is a prolonged use of radioactivity. Now you can study this one, but the basic idea about the radioactivity I have given you. Thank you.